All right, folks, what we're going to try to do today is get our data for our salicylisis of the t-pentyl chloride to t-pentyl alcohol. And what I have here on the data on my Excel spreadsheet right now is just the data from the actual lab. So our time in minutes and the NaOH that was added. All right, I don't really want to study the NaOH that was added. I want to see how it compares with what the t-pentyl chloride would have been. So I want to look at the difference between the maximum amount added, so the concentration at time infinity, minus the amount that was added, NaOH, because the part that's not there is probably the t-pentyl chloride that's not reacted. And we are going to get that by taking that value that's in B14, and I want to use that column for all these calculations. I'm going to put these little dollar signs, and then I'm going to subtract the column next to it, the B6, and then I'm just going to, what the heck? Oh, I did B14, that should be B15. I was going to say, that should be closer to like 10. Yeah. Then I just select that, hit copy, select all the ones below it, and hit paste. And now I don't have to recalculate that formula each time. Right next to that, I want the natural log of that value. So I want the natural log of the NaOH difference. And get that by taking natural log of C6. And just like we did before, I will click on that, hit copy, select them all, and hit paste. Alright, now you might need to change the formatting here. I've already done that on mine, but you will probably have a lot more digits, and you can make those go away by right-clicking on that and clicking here number format, just choosing number and changing that to the decimal places. Technically I should only have 3 significant figures because that's the most I had over here. So I'm just going to change that so it's 3 significant figures. Alright, now what's interesting is I kind of want to actually graph that piece of data against, oop, I did that wrong, this bit of data and this bit of data. But if I actually choose just the stuff I want on the web form and then go to insert on and click on my charts, you see how they're grayed out? You actually can't do this on the web form. You can't select 2 different data. If I select the entire table, they stay visible. So what I'm going to do is I'm going to hide the 2 columns I don't care about. So I just select them and hit hide. And now I'm going to select the data I actually want to plot. And I don't want to hit that even though that looks like a line graph. I actually want to go down here to our scatter and choose something like this. So I'm going to do a scatter with line markers. And there's the data. Now right now it's not super in good shape. So there's a few things we're going to do. First off, I'm going to get rid of the legend because since there's only one piece of data, we don't necessarily want a legend. And we're going to label our axes. So our horizontal axis is the time, and it's in minutes. And the vertical axis is the natural log of need other parentheses, NaOH infinite minus NaOH added, close parentheses. And I'm going to go ahead and make my title above the chart, but I'm going to say what this is representing more than anything. So I'm going to edit it, and all that went away. I'm going to say this is the rate of change of t-pentyl chloride to, actually I'm not going to say rate of change, that's going to be too long. T-pentyl chloride, probably should have a capital P, to t-pentyl alcohol. Because that's what we actually did in this lab, so I'm saying what the graph is actually representing. Now there's something else I want to do. I don't like that my line's up here at the top, so I'm going to hit Format here and choose my vertical axes. And right now it has a high range of 2.5, which is good. That's about it's about 0.15 above here. So I'm going to do 0.15 below and say my minimum is only 1.3. And that should spread that out. Now, if you're doing this on Excel that is on your computer, you can click on this graph in one of those lines, and you could tell it to add a trend line. Well, that's not something you can do on Excel for the web. So we're going to calculate it using a cool little equation. And it is line est. And I need to put an equals in front of that. Line est, and you notice how it tells you what it wants. It wants the y's in there, and we're going to put our y's in as the natural log. So I'm going to say the y's are d6 to d14, and then the next thing are my x's, and that is a6 to a14, and then I just close those parentheses, and what I have is my m and my y-intercept. So this is a straight line, y equals mx plus b. That's your m, that's your y-intercept. And that seems right because we're right around 2.3 now, so at 0 must be at 2.38. All right, and we also want to get that r squared, which tells you how good the data is, and we can actually calculate that as well. So its command is equal rsq. And you notice how it says known y's and x's? We're going to do the same thing. So our y's are d6 to d14, and the x's are a6 to a14. And we just calculate our r squared value. So I got an r squared of 0.9979, almost 3 nines, 998 if we round up, which does tell us that almost every single one of those points is right off of that equation that we could get. So we're not going to graph our trend line per se, but we actually can get our data, and we can talk about our r squared and mention that we're very close to having a very straight line. So give me the chart, make it nice and pretty like that, and then tell me something about your little data. So what your equation for that line is, what your k is, because that is that value right there, the 0.0287 is my rate constant. And the 997 tells us how confident we are that this is good data. And the closer to 0.99 you have, the better it is to be in a good data.